Now we're going to take a look at a significance test or a hypotheses test. And our null hypotheses, in most cases when we are comparing two proportions, our null hypotheses will be to say that there is no difference between the two proportions. Remember, what we're trying to show is true, we generally put in our alternative hypotheses. So my null hypotheses in symbols would be P1 equals P2, and remember there's no P hat in my null hypotheses. I'm talking about the true proportion, and so in words I would say the proportion of smokers who stop smoking is the same for each group. Then my alternative in this particular example is that the support group helps smokers using the patch to stop smoking. Now, the reason why I chose a right-tailed test, a one-sided greater than test, is if you look back at the problem, the question says, do these results suggest that such support groups could be an effective way to help people stop smoking? So there's that suggestion in that question that the group that has the extra support besides just a patch, that they're going to have a higher rate of stopping to smoke, so we would have a greater than test. So if the question had said, do these results suggest that the support groups show a difference between the group with the patch alone, then I would do a not equal to test. So it really does depend on the type of question that's asked. So in our null hypotheses, notice that we're saying there's no difference in the groups. So we're kind of treating this like one big group because we're saying there's no difference. It's all the same. So because there's no difference between the two groups. So because we do that, we're going to do what's called a pooled p hat value. We're saying it all comes from one big pool, you can say. So we pool the p hat value, meaning that we're putting the two groups together. So my pooled p hat value becomes the sum of the two my two values that I ended up with. So P1 plus P2. Actually, I shouldn't call those P1 plus P2. I should call those X1 plus X2. I'm going to change that. That's a little better. So my p hat value, or my pooled p hat value, becomes approximately 0.259. So this is the pooled p hat value is what we use when we calculate the standard error. Now remember the difference between standard error and standard deviation. I'm using my p hat value, and so because of that, that's why I call it a standard error. So we're going to use the pooled p hat value, the pooled q hat value. So this becomes my standard error. Now another slight difference for a significance test is when I check my counts, because I'm assuming the pooled value to be the true sample sample proportion, then I'm going to use that for my checking my conditions. So it should be N1 times my p hat pooled. So I kind of made those calculations down here. So that would be another slight difference. Because I'm assuming that they all come from one group, then I would be using that value to check those conditions. Other than that, the conditions are the same, and we've already discussed those and met those. So since the conditions are met, I'm going to use a z-test for the difference of two proportions. Now on your yellow sheet, you'll have this printed out in words. The standardized test statistic is the statistic minus the parameter divided by the standard deviation of the statistic. So in this case, my standardized test statistic is z. My statistic is the difference between the two p hat values minus the parameter. Now the parameter, that's like what you have in your null hypotheses. So my parameter was to say that there's no difference. Well, if there's no difference, that means the difference is 0. So my parameter is just 0. And this is actually from your yellow sheet. This is the same formula that I listed previously, just on the prior slide here. It is the same as this one. It's just factored out a little bit, so there's just a little bit of simplification. The reason why I wrote this one down is because this is on your yellow sheet. So if you look at your yellow sheet and the denominator, you will find this printed on your yellow sheet. Now, typically, you're not going to be using the formula and plugging the values in yourself. You're going to name the test, and then you're going to be using your calculator. So on your calculator, you would be finding stat, test, And this time we want a two-proportion z-test. So again, you want to make sure you name the test that you are doing, identify that after you've checked your conditions. Now, since we already did a confidence interval, it leaves the values that I had before. You do need to come down and make sure that you choose the right-tailed test. And again, that was how I set it up because of the wording of the question. So now I'm ready to calculate. And here's my information. Now I'm given a z-score, so I have a z-score of 2.4. Remember, that means that my difference that I am observing is 2.4 standard deviations above the mean. The next value down where it says p equals, because you'll notice a lot of different p's. This first one is your p-value, 0.008. Then you'll see the p-hat values that we have for our two samples. And right here, the one that just says p-hat, that's your pooled p-hat value. What you're looking for here, the z-score, you should really write that down, what your z-score is. And if we were going to draw a picture, we could show that. And our p-value is what we're going to use to help us determine make our conclusion. So since my p-value is 0.008, here would be my conclusion. And you can see it's kind of long. If there is no difference between the two groups of smokers, that's like saying if the null hypothesis is true, except what I said is better because it adds context. If there is no difference between the two groups of smokers, then the probability of the group with the support meetings being so much more successful is 0.008. This is very unlikely to occur by chance. Okay, this is pretty small. This is unlikely to occur. This provides strong evidence that the support groups, I guess that should be help smokers stop overusing the patch alone. So this does provide us with that strong evidence. We have a low p-value, so we reject the null hypotheses. But notice that nowhere in my conclusion do I say reject the null hypotheses. Even though it's not wrong to say that, but I've kind of said it without saying exactly those words, because I've said that I've been given strong evidence that the support group helps smokers stop overusing the patch alone, which is like saying I'm accepting my alternative hypotheses. So that gives you the whole process. Also notice that in my conclusion, I have defined what a p-value means. My first sentence is describing what a p-value means, and then below that, I make my decision that I have the evidence that the support group helps smokers stop smoking over using the patch alone. So this is the process for inference, both the confidence interval and a significance test for comparing two proportions.